This is the second in a series of videos on the titration of a weak acid with a strong base. Now, when I'm making these videos, I'm assuming that you've watched the previous ones. So if you haven't watched the previous videos and there's something that you don't quite understand, you may want to go back and look at the previous videos. So in this case, we want to know what is the pH after we've added 25 milliliters of the base. And so when we've added strong base to the weak acid, the problem is always broken up into two steps. We first do a stoichiometry calculation. For the reaction of the strong base with the weak acid. And then the second step is an equilibrium problem, where we deal with what's left. Essentially the leftovers of the first part. So the first thing I need to do is write down the chemical reaction. So I have my strong base, sodium hydroxide. Because it's a strong base, it's going to completely dissociate. So I don't really have NaOH. What I'm really interested in is the hydroxide ion that it produces. So I have OH minus, and the hydroxide is going to react with my weak acid. This reaction is going to go to completion, so I don't use my equilibrium arrows, I use the one-sided arrow, and that's going to produce water plus the conjugate base of my weak acid. All right, and so this is stoichiometry, so I like to make tables for these, but I use the BCA tables instead of the ICE tables because we're not doing equilibrium. And remember, whenever we do stoichiometry, we always have to work in moles. So I want to calculate the moles of hydroxide and nitrous acid. So for the hydroxide, I'm going to use the molarity equation. And so to get moles, moles are equal to the molarity times the volume. So I have 0.5 molar NaOH times, need to convert the volume into liters. And so I have 0.0125 moles of hydroxide. And I'll do the same thing for the weak acid. Okay, so I can go ahead and put these values in my table here. So I have 0.0125 moles of hydroxide, 0.08 moles of weak acid. The water is in all these problems we don't really care about. And initially I have no moles of the conjugate base. So now I need to look and decide which one is my limiting reagent. So in this case, I've got less hydroxide than weak acid. So the hydroxide is going to be my limiting reagent. So the change and then the products will be positive. All right, so at the end of the strong base weak acid problem, I have no strong base left over. I've reduced the amount of weak acid and I've converted it into its conjugate base. And so now I'm at the second part of the problem. So now I have an equilibrium problem with whatever is left over. And so I don't have any strong base. I have a weak acid and its conjugate base. So in essence, what I have now is just a buffer. And so to calculate the pH of a buffer, I'm going to use the Henderson-Hasselbalch equation. And we'll do that on the next slide. All right, so I've just reproduced the same table that we had in that we generated on the last slide. I've just colored it in red. So That step 1 was the stoichiometry step. And now step 2, we're going to do the equilibrium with what's left over. I've got a weak acid, its conjugate base, so I have a buffer. So I can just plug the concentrations into the Henderson-Hasselbalch equation, and I'm good. Now generally, when we use the Henderson-Hasselbalch equation, I need to use the concentration of the base and the concentration of the acid. And in this table, these are the moles, not the concentrations. However, because the volume that the acid is in is the same as the volume that the base is in, when I divide by the volumes are the same. When I then plug them here, the volumes are just going to cancel out. And so I can save myself some time and just use the moles and plug the moles directly into the Henderson-Hasselbalch equation. The only thing I need in order to do that is the pKa. I have the Ka. So the pKa is going to be the negative log of the Ka. So I get the pKa to be 3.33. So then the pH is just 3.33 plus the log of the concentration of the base, or in this case I'm going to just plug the moles directly in, over the concentration of the acid, but again I'm just using the moles. And so when I do that calculation, I get 2.59 for my pH.